just like to say thank you to everyone for attending today's AMA. With our co-founders, our Chief Technology Officer, David Beberman, is here to answer questions. And additionally, we have our co-founder and Chief Marketing Officer, Jay Moore, to join us and engage in the conversation. So thank you, gentlemen, for being here. And now I will hand it over to Jay.
Dave, it's been a very busy couple of months. We launched Saga Python at Consensus in June, and then just the last couple of weeks, we've had the patent for the Saga OS get granted, and then got to announce the available source over on Saga Node of our code being available for people to download and start to take a look at. So I think it's a great opportunity to get a minute of your time and just kind of talk about maybe how you see the progress going, what things you think are really important for people to focus on as they're coming up to speed on our technology, and then also, what it is that we're looking for, as people are starting to contribute. So I figure that's a good conversation to have, and just want to kick it off. Give us a little bit about where you see Saga being at this point.
Thanks, Jay. Thanks everybody for joining. That was several points put together. We have had a very busy summer, and a lot of really good things have happened. 2 of our patents have been granted. We do need to file more. Those are all defensive patents, by the way. They're intended to protect us until we have a mainnet running. They're not intended, and then they'll be released to the public. They're not intended to be held by us for any means to stop people from using our software. We did release, put up on a public server, both the Saga Python code, which is continuing being updated, and the framework for Saga Node, which is the consensus algorithm. The rest of what would run the blockchain. Saga Python's continuing. We will get Saga Node rolling shortly with more development back on it. Right now, we're focused on finishing up the alpha version of Saga Python. Going pretty well. There'll be another release of it next day or two. Literally just going through last couple pieces to handle some issues with Python, and it should be, and also adding some comments into the README to give a better explanation of what's going on there, and it should be ready to try out and learn from. To be clear, it is the back end piece. It's the execution engine for Saga Chain. It's not the front end piece. So what you'd be doing is, so I'll write it out in detail, but there's what you're doing right now is learning what the classes are, how to use classes and objects, accounts, those types of things. Not so much how you would actually do a client to talk to the blockchain yet. That's still to come. Jay, I forget, you threw like 4 questions. What was the next one you threw?
No, I was just kind of giving an overview of what we'd be talking about. But to that point, I mean, we've been working towards getting these this next step, and like you say, you're able to see the kind of the alpha version of Saga Python, and when people are starting to come up to speed on that, we've got some of the foundation classes exemplified there. But like you say, we're just now getting some of those early building blocks created. What do you think it's important when people are approaching this to understand about how we're writing smart assets versus how you might have addressed them with other technologies?
All right, so let me start off with things have changed. Bitcoin's now a decade old. Right? In the computer world, that's a dinosaur, right? Not that I have anything. I think Bitcoin's great, by the way. That's not the point. The point is to think in terms of how many innovations happen across that time frame. We're a new innovation. If you're a blockchain developer, blockchain user, you've heard of coins, tokens, and smart contracts. We took a very long look at that, and they're all very, it's obviously all of it's worked very, very well, not to take anything away from it. But if you look at it from the point of view of future scalability and capability, you run into a difficult wall, implementation wall. And you can see, in fact, in the EIPs that Ethereum's doing, that they're doing a lot of what you would consider workarounds to accomplish things that could be done much easier if you use the object model that we're using. So it's a very, very key point. What it means, though, is that instead of viewing a smart contract as the place where you have a token in and you send messages to, and there's a single smart contract, what it means is that is you have an account and everything's within that single account. So instead of being smart contracts as the only there's only two concepts of objects in Ethereum, the smart contract and the individual account. I'm talking about the blockchain side, not the programming language. And from the blockchain side, those are the only two things that are available. On the account side, the only thing you're allowed to do is send a message to add or subtract Ethereum. That's all it actually can do. On the smart contract side, you're only allowed to send messages to it to kick off individual functions that are registered for it. And that's it. There's nothing else you can actually do at that level. It may seem, it's all the wonderful things we can do with it. However, at the fundamental level, those are somewhat limiting. So what we have in an account model is that the account objects, instead of being monolithic that can only take one type of message, the account objects themselves can contain other objects which have other code associated with them, other class code. And so an account can grow over time with what its data is and what its functionality is. And this is a very different model. So you don't, although you can certainly re-implement the smart contract model with our system, you don't necessarily need it. What you need instead is to be able to put objects into accounts, so to speak, referenced by accounts is probably a better way to put it, and then be able to send messages to those objects. This will take a while to get used to, and I guarantee you that there will be people coming up with application solutions we haven't come close to thinking about. What it does, though, and this is the key takeaway of all of this, is a real question of why go through all of this. Fundamental thing we see in the blockchain world today is how do you continue to scale the capacity, meaning the amount of transactions that can be handled per second over time. Not just you get a blockchain that runs fast, but how do you get the blockchain to continue to increase its capacity as you add more resources to it? And by resources, we mean more nodes. The account model and this object model is a critical piece to make that happen.
Yeah, no, that's exactly that's exactly the conversation I wanted to have, because I think when we're describing this to others, having a context for how it differs from the smart contract approach helps them to understand how we're different. Talk a little bit about how the class tree and the calling of the actual functions off of the operating system is very similar to how we write software and write applications for lots of other devices.
So first off, the language that we're currently using for writing the transactions and classes is Python, with a lot of modifications at the application level to make it do what we want. But the underlying syntax is Python. We're not tied to that. It is possible to use other languages, but there's certain things they have to be dynamic, garbage collected, compilable, interpretable. There's all sorts of pieces. It's not really necessary to go through them right now. The way I can explain this, though, best is that if anybody on here has written in any object-oriented programming language, and that includes even Solidity, if you've written in Solidity, if you've written in Java, if you've written actually in Python, if you've written in actually JavaScript, if you've written in anything where you can define classes and create object instances of them, what you tend to do is you write a program, and inside the program are the classes and objects. And to get the classes, you might load them out of a shared library, but you have them in some sort of namespace, just like URLs are namespaced. and you can call them. And in fact, you can have namespace collisions. If more than one library uses the same name, you tend to have a problem. And then there's workarounds for all of that. Think of Saga Chain from the point of view of the classes, one giant application. All the classes have unique names, which happen to be secure hash IDs, 256-bit hash IDs. Each account then is an instance of an application. It runs permanently. It doesn't start or stop. It's persistently stored, transparent to you. So when you send a transaction to an account, whatever state it currently has, it runs, and it runs whatever code it is. Okay? So it's like your applications start and never stop. They just kind of automatically freeze after the transaction's done. And whenever you send another transaction, they come back up, start, do their whole thing, and all the state gets saved again. So it's really neat, and it's basically taking the concept of actually the application concept and making it global and permanent. I don't know if it's hard to grasp. People have a hard time grasping this concept because they're very used to the classes and objects being part of a single instance of an application that you start and stop. You don't start and stop applications here. You create accounts. You can delete an account. Once you delete an account, then sure, it won't be there anymore. But generally, the idea is you're going to create an account and keep it there forever. I hope that helps. It's a different type of mindset here. So don't think applications, don't think programming languages with classes in them. Think accounts are your applications, and the classes, essentially think of everything as shared library of classes. The classes are physically on the blockchain too, and so it's kind of like everything's a dynamic shared library class environment.
Fantastic. Actually, we just had a question while you were getting into that, asking if you could go into more detail about this account system.
Well, so there's more to that, Jay. Ask your next question. We might go back to that because there's some real detail of why we're doing the accounts, but we can get back to that. Go ahead.
Yeah, no, I think that's part of this. Well, I mean, to that degree, is people are writing their applications using this new approach. One of the things that we've seen as we've worked with different use cases around blockchain is that it's very difficult using the existing smart contract approach to solve some of these more complex application environments. How does this open up a playing field to be able to address some of the more complicated problem sets that blockchain can solve?
Oh, that's funny because it actually pulls together the account question too. Generally, in our environment, you're not sending a message to a given smart contract where it's doing everything inside the smart contract. You're sending messages between objects in accounts. When you're writing a transaction script, it's actually a small program. So it's Turing complete, all those things, and it uses gas units to make sure you don't loop and eat up all the memory, but you could certainly write a loop in it easily. And that is also written in Python, by the way. So it's totally normal to be able to send messages to an object in one account, read the data from it dynamically in the transaction, and send it to do a message to another object in another account. It's also possible to maintain references between objects from one account to another. Although that sounds very abstract, what it allows you to do is things like create an entire sales process. So in a sales process, you usually have either an offer to buy or an offer to sell, right? A quote or a whatever an offer to buy looks like. And then you go from, say, a quote to a purchase order to a delivery to an invoice, all those pieces. If you think of those as objects and they reference each other across accounts and messages that go between them, with appropriate signatures and protection, all of that, you get, in fact, an entire sales process that can be carried out on a blockchain. And it's all built into the code there. So it's very possible to do things like say that you're not going to accept a purchase order for a specific quote because it didn't have the right fields in it or something like that. And that can be automated in the code base on the blockchain. there's lots of other things. One more piece in that space. Imagine that you're trying to do a transaction with some other anonymous entity, and it turns out that an anonymous entity is in North Korea, and you obviously don't want to be doing those transactions with somebody in North Korea. So one of the other pieces that just becomes fairly trivial to do is put certificates of authentication of whatever certificate source you will trust into the account as a list of objects. And then when you go to do a transaction of some kind with that account or an object in that account, your code can then search for a certificate that is valid for you that proves, hey, I want to do business with you and you're not North Korea. So lots of things just become a lot easier with this type of environment. And you don't have to solve all the problems today is the point, because you can add new objects dynamically to your environment. And when you do that, you're adding new code to your account rather that essentially imports that code. You don't have a fixed amount. And it's like I said, it takes a lot actually to work through your mindset to change how we've been thinking about doing applications in the blockchain.
Yeah, and I think that's that. I mean, that's the exciting part in terms of the innovation is that you're going to have the ability to maintain this code, the ability for the code to get hardened, and make sure that it can get used across lots of different applications as time goes on. Disco was the one wanting to know more about account system, but he also asked a question about speaking about programming languages. He says, my best friend's a JavaScript guy, doesn't do Python, unfortunately. I know there are more Python users than Java, but do you guys have any plans to create some sort of Saga Java in the future?
So actually, the way we're designing the system is to be language runtime independent. Python's the first one. Assuming everything gets out the door on timing in the final version of it, you would be able to add a new language dynamically to the system. Now, there's some pieces to that. So literally, you'd be able to specify a new language runtime. You'd have to guarantee availability of that runtime to be able to be pulled into all of the nodes on the blockchain. And you would be able to mix and match your code between the various languages. What I mean by that is if you wrote a class in Python and you have some other language that you wrote another class in that you want to inherit from the class in Python and still send message and have everything else work, it will. That's the intent of being language runtime neutral. There's certain languages you can't do, of course. Anything that is fixed, compiled, we won't allow. In other words, everything, this is a blockchain. We don't want to allow people to obfuscate their code. So in fact, even with Python, we're putting the physical source code, not even the compiled code, on the blockchain. So we're going to require that for any language that's on the blockchain. So essentially, you'll be able to inspect all the code of all the classes at all time. But the idea is to be able to set up so other languages can be added. Whether or not the Prasaga Foundation takes that on, or we have some project with anything from a company to a university, that's up to them.
But the intention of the technology is to be multilingual, as long as it's object oriented. And actually, kind of along that line, but I think this is maybe something where it will help to frame this. The question is about what are the advantages of Saga Python compared to Rust and C++ and Python. Just understanding what it is we're doing with Saga Python, how it works, might help for people to understand that.
Rust, C++ are fully compiled languages, not garbage collected, and dynamic exec of methods is very difficult with them. I'm sure somebody's going to tell me, yes, it can be done. Of course, you can dynamically compile and store and make them work and figure out how to do it. The reason why I went with Python is generally because it's very, very well developed in terms of introspection. So pretty much you can write Python practically in Python. And you can get at the entire type system. You get all sorts of wonderful things with it. So it becomes relatively easy to use as a platform for implementing this. There's nothing really, unless you're looking at a fully compiled language, there's nothing really stopping you from building other languages. Like I said, we won't really. The other one is that obviously for security reasons, you don't want to go with a system level language like C++, for example, which makes it possible for somebody to create a class and put some code in there that, as far as the execution engine goes and the blockchain goes, it all executes correctly and you get a valid transaction, but in fact, it's a virus attacking the system. So you don't really want those types of languages. We don't expect to use those. Anything, of course, with a pointer to memory is going to be verboten. But that's basically it. It's just literally that Python's a very, very well developed, relatively easy language to use, easy to extend. As it turned out, we haven't actually we haven't added any new API functions to it that are not written in Python. Matter of fact, which is kind of really nice. Everything we've done for Saga Python is written in Python, which is actually a nice.
Part of Python is the syntax that you need to have to write classes and objects in our technology.
Yes.
Okay.
Oh, absolutely. And we do an awful lot of keeping even though the actual implementation isn't using a lot of the internals of Python for certain things. In other words, the default means of when you send a message to an object in Python goes through certain hash tables and various things. We override most of that for the methods that are exposed as classes on the blockchain. We call it the class manager infrastructure. From the user's point of view, it looks like you're still running straight Python code. You don't have there's a couple of things you have to put what's called a couple of decorators on there that say this is actually Saga Python code, not regular Python code, and things like that.
The next question comes from Digirati, and he wanted to know, where does the data sit on the blockchain? And I think that comes up a lot, and we end up talking. We don't know if we want to get into enclaves today, but talk about the data piece for people so they understand.
There's a misconception in general about blockchains. The only part of a blockchain that is necessary, that is actually stored and recovered, is literally the blocks themselves. Okay? Everything else is something that's a local matter. Okay? So in a state approach, which is the way we view it, you really, if you're just a node running, you really only need the current state. And remember, this is a local issue, not the blockchain issue. And as you get new blocks in, you update that current state. Okay? This goes for pretty much everybody. Even Bitcoin really is state-based. The states happen to be Bitcoins themselves. In reality, the blockchain itself is the only thing you would store if you really need to store it. You don't really need that online anyways. And even the original Bitcoin paper explains that very well too. The second question, though, is when you're making accounts with objects and state in them, which essentially takes the place of the smart contract model. And I would say that in terms of the local state information you need to maintain, it is going to be larger. That there's no question about that. You want to be able to do, you get a choice. You want to keep more functionality, you tend to have to keep more data. That's how it works. There's a couple things we have looked at on that. One of them is that you can always delete objects. And when you delete them, again, as far as the blockchain is concerned, the transactions are permanent. The transaction would literally be delete object. The state, of course, your current state no longer needs that space. So you get into a possible state expansion situation where people keep adding more and more state to the blockchain. They just, you can add whatever they do things. A couple of thoughts on that, because that's a common problem for everybody. One of them is that when you're paying for a transaction, which we use a gas unit concept, one of the things we've been looking at is to have a surcharge based on the total size of state that a given account is currently storing. And so what that does is it says to the node operators, we'll reimburse you somewhat, the blockchain will reimburse you somewhat for the fact that you have to store this state. And we're also looking at an aging factor, that the longer you have to store it, the higher the cost of doing a transaction with it, so that somebody can't create an account, put a bunch of state into it, and walk away, and 5 years later say, "Hey, I think I'll do one transaction with it," and you're stuck. Meanwhile, all the nodes in the system are maintaining that state. To be fair, by the way, every other blockchain has that same problem, of course. When it comes to things like doing very complex, one of the things we've shown a lot of is things like the supply chain approach. We talk about being able to handle a car with 1 million parts in it and 1 million references in it. You would never want to have the entire blockchain, all the nodes on the blockchain storing. Imagine if every node, every server up there had to store all of the parts for every car on the road, and there's 100 million new cars added every year. I don't think we all want to have as much memory space as Google's cloud center over in Oregon. So what you do instead, of course, is you create what we call private enclaves. These are shards of the system that have pieces of data that are only maintained among the nodes that care about them. And those aren't actually stored out on the rest of the blockchain. And you use normal hash verification, ZK snark type things, whatever's necessary to provide that whatever information necessary to verify across the rest of the blockchain.
Coming out of that conversation around gas, a question of how and when are gas fees executed?
So the transaction is going to work very, very similar to what you would see today. You're going to pay for gas. The gas units are tied to the bytecode instruction execution. And by the way, if you put any other language runtime, you have to actually have some sort of counter. I don't care what it is. For the Python world, it's actually the main interpreter loop, if anybody's interested. And you will get the gas units subtracted from it. As I said, we'll have a couple other pieces in there, probably surcharges around managing data. And when you do a transaction script, you are when a client creates a transaction is actually a transaction script. It's actually a small program. There are 4 specific functions that you have to have in there. Those are assigned with a header that includes how much gas you're willing to put in and what you're paying for it. That's literally this. The header looks different, but the data is the same as you would for everything, I guess, but Bitcoin. Bitcoin, of course, just does a straight UTXO. Once it gets executed, there's a little detail actually. Let me drill in one more level there. When a transaction gets included in a block on a given shard, and there's little details about managing that correctly. One or more nodes. So we have a validator set of nodes, and we call a hashing set of nodes, the miner set of nodes. Someone wins, or on the validator side, somebody wins on the miner side. The validation side, of course, is randomly selected. There's no proof of work there. And we have a leader protocol, so leader gets it. And the transaction fees are split up on a known set, which is currently 70-30. 30% goes to the validator and leaders, 70% goes to the miner. And then we take the treasury, which is a DAO on the blockchain itself, takes a cut of every transaction, a small percentage. The percentage may vary again with the DAO. The reason why we do that has a lot to do with economic management of our currency, which goes into a whole nother level of discussion. We work with a PhD and one of the global well-known people on managing national currencies. So we're going to be using that model. I don't want to go down that path. Just trying to answer the question of
that's
what do
another
we do with
AMA I'm sure
transactions.
we're going to have.
Yes, that's like a 500-page book. Are you kidding?
Yeah. Well, and out of that, there was a question here that says they understand that we started as an IoT solution, and when we reviewed other chains, we decided to build our own layer 1. And this could probably be a very long answer, but how did you come up with the concept of this way of having a blockchain be able to scale?
How did we come up with it? We spent several years. Look, we started with, okay, So we had a nice architecture for doing managing multiple message servers. This is a concept for like chat servers, those type of things used for IoT and industrial Internet of Things, and works very well actually on paper. And you would use the blockchain to control the flows, meter them, get paid for them, all those type of really nice things. And so if you wanted to collect data from, say, I don't know, 1,000 thermometers around the world or something, you were willing to pay for it, you would have, somebody would be advertising that capability. You would assign to their smart contract. The smart contract would have a listener that turned on the message server. You would validate that the data was streaming, and you would periodically post. Ethereum at that time, this is 2018, was having trouble with its transaction fees and also the time it takes to do this. You can't really, it takes time to get a transaction through and finalized. We looked at that and said, oh, well, we can make that work, but there's going to be drawbacks to it. And why don't we take a look at the blockchain itself, see if we can do something there. So we looked at lots and lots and lots of protocols, Casper, Casper's CBC, correct by construction, Algorand's, going back to Liskov's work, going back in, the fundamentals of Byzantine Faltons with the Byzantine generals algorithm, and on and on and on, and looking for how do we scale. And the first thing that's very obvious in a blockchain world is you have to think of it from the point of view of CPUs and multi-core. I'm talking to you on a cell phone today, probably with 16 CPUs. Whatever you're using has many, many CPUs, and they're called cores, but a single chip with all these cores in it. Question is, why do you have that? And the answer is because we hit the wall on how fast we can clock a single CPU. And that's true. We've pretty much clocked them out at whatever they are, 2.5 gigahertz, 4 gigahertz, something like that. You make the transistors any smaller, and they're not transistors anymore because there's no atoms left on the transistor. And if you go any faster, it burns up because you can't dissipate the heat fast enough. In fact, people don't know this, but if you were to take your cell phone and max the clock speed on all the cores at one time, it'll catch on fire. It literally can catch on fire doing that. That's why there's built-in throttles and all that type of thing. Our viewpoint is think of a blockchain as a CPU. You can make it go faster, and there's several of them that actually will go fast. I mean, Solana has done everything I can think of to make a single chain run really fast. Many others have done that. You have limits on network latency. You have limits on various things, and the faster you go, the more demand you make on having homogenized hardware and all those types of things. However, if you want to continue to expand after that, you have the same solution as the CPU market. Just like the CPUs hit the wall at whatever the clock speed is and went to multiple cores, blockchains have to go to multiple blockchains or shards. They have to be able to run in parallel, and they have to run as much as possible independent of each other. Just like in a CPU system, if you have data that multiple cores need to write to, then it has to be serialized, and you block all the cores up. So you don't get if I have 4 cores, I don't get 4 times the throughput. If they're all trying to read and write the same data, it's just only have one CPU. And if you look at the architecture of a smart contract today, where especially if it shares data with other smart contracts, you see the same equivalent of serializing and blocking up the system, no matter how many things you could do possibly in parallel. So when we look at it fundamentally from a high-level architecture viewpoint of how to scale, it becomes very obvious that you need 2 things: multiple shards and independent data. There's an acronym for it, but it means that one shard can be working on one piece of data, another shard can be working on another piece of data, and they are completely separate, independent of each other. And if you can accomplish that, the more you can accomplish that, the more you can scale with shards. If you can't accomplish that, and you start finding out that you have to do cross-shard communication and blocking between them, then you end up at the speed of a single blockchain. That's the fundamental piece that all of this is built around, trying to enable that.
Yeah, thank you for that. I think that's part of the process you went through, especially when, what was it, Easter morning, you said the problem is smart contracts in 2019, and that those are going to inherently serialize. And obviously, you've done a lot of thinking about making sure that we could do parallel processing in the blockchain itself, but getting that transaction layer to be in an operating system, the logic being able to be called from an operating environment really was that next step of innovation, right?
Well, yeah, I mean, let me put it this way. I can tell you exactly how to shard the system. We had that. The problem is, okay, how do you program it? That's great. That's wonderful, except, there's no model that allows you to separate the code and data. And that's what we did.
Well, I think that covers most. And there are obviously more things we could get into about why we're better than other chains and what makes us the all the characteristics that makes us best. But I think we've addressed that in some other conversations. When you're thinking about the Saga node and what we're doing to engage with the ecosystem to assist us, maybe you could give a little bit of direction as to what you think is next for getting those kind of contributions. I mean, obviously, we want them to understand what we're doing first, and then within that context, be able to assist us with some of the. I mean, your list of all the things that need to get done versus the list that we can kind of lean on the ecosystem, the community for kind of separate lists. But what are you thinking as far as your expectations to see come up next?
Well, let me break it into three parts. Okay, the first one is all infrastructure. Everything from the internals of the nodes to the Saga Python itself to those types of things, debugging tools. There's lots of pieces that need to be done there. There's no IDE, integrated development environment, specific for Saga Python. There's a Python IDE, but it's not. You'd want to do something very specific for it. There's a lot of pieces like that. Then there's the general tools that you would expect, general user tools that you expect. I don't think the word wallet's going to be the right term for what will be used for the client side to work with, to interface with the blockchain, with Saga Chain, but we need those types of capabilities. There's no blockchain scanner tool yet. There's in our environment, there's also something called a class browser. You're going to want to be able to browse, or a class dictionary browser of everything that's actually on the blockchain. There's no visualization tools or anything like that. From the applications viewpoint for specific vertical market things, that's just wide open. I mean, there's, one of the things you ought to be able to go back and do is, after all of this, you can actually implement a message server dynamic environment for selling IoT data. The entire original design is actually doable. Yes, and a lot more. I don't, there's, and of course, let me back up, all of the regular financial things that we've all learned about to do on a blockchain are all doable. You can build all of those into a Saga Chain as well, and they will run and hopefully run as well or better than anywhere else. I suppose we haven't really touched on, but one of the core tenets of the end product, which is a result of scaling, not an input to scaling, is that we should have a currency in Saga Coin that is relatively stable. And I don't mean in terms of the word stable coin. I mean relatively stable in terms of its purchasing power, so that it'll be possible to use Saga Coin, and our goal is to use it in the same way you would use any fiat currency, and be able to maintain it, keep it, and not worry about tomorrow half of its purchasing power eroding. Lot of details on that, but when you put those pieces together, there's lots of things you can do with it. So when you ask, where do we? So what I do is I break it down. I said into 3 areas: the infrastructure, think tools, think applications.
No, and I think that's that. I mean, obviously, each one of those in some ways has different talent attached to it. Being able to get the solutions done for applications different than the tool set, and obviously the infrastructure is even probably a heavier lift. But those are all things that we're looking to the ecosystem to assist us with, and I think that gives a nice short list of things that are top of mind for us. As time goes on, I'm sure there's going to be a lot more dialogue on that, both on GitLab and in our Discord server here. So that's exciting. Well, thanks, David. I think that's we went a little long, but I think that was a really good explanation to help people to get their heads around how we're different and what we're doing with Saga Node and Saga Python, and obviously the Saga OS that we now have the patent as of the 6th of this month. So thanks again. I appreciate it. And we'll look forward to having you again as soon as we can pry you away from the code long enough to do another one of these.
Thank you both, Jay, and thank you, David, so much for your time and your insights. Thanks to everybody for attending today's community AMA. We'll be having many more of these in the future, so stay tuned to our announcements channel and our social platforms, and we hope to see you all again very soon. Thank you so much.